my screen here. How does that look? Oops. Cool. All right. So as Betty said, my name's Rick. I'm an engineer at Solo, and today I'm talking about the Gloo architecture and underneath Gloo, how Envoy fits into that. I'm going to, at the top, I wanted to just say my goal for here is to start high level, but really go pretty deep into the architecture of Gloo and how we interact with Envoy. I would love for everyone to be able to take away a sense of not just kind of the big picture, but also what components do we ship with Gloo, what configuration do we manage, and generally kind of why we've architected around Envoy the way that we have. And then and that's for kind of open source. So then I want to look at our enterprise product and how we've extended the open source with additional capabilities. So to start things off, we often are talking to customers, organizations, and they're ultimately thinking about a few different transformations. So often, and organizations will have monolithic software. Maybe this is deployed on-prem somewhere, on VMs, could be migrated to a cloud provider at this point. Often organizations are kind of in the process of moving away from that as a development pattern towards microservices. But that also introduces complexities around where they run. Are the services running in containers? If so, are you using a container orchestrator like Kubernetes? And generally, there's just a lot more things to manage once you start working with microservices. And then on the other end of the spectrum, we've got organizations that want to take advantage of new managed offerings such as AWS Lambda or other serverless capabilities. So the idea of an API gateway kind of evolved out of some challenges related to, as you're moving in this direction, how do you manage your APIs? How do you actually expose this application to your outside users in a coherent way? And while doing that, you need to think about security. So externally, you need to protect yourself against malicious traffic coming in. You need to make sure that users who are accessing resources or data are actually authorized to do so. And generally, you want to make it easy to onboard new services. So, make it easy to bring up Service 5 in this picture and troubleshoot when something does go wrong. So the Gloo Gateway, this is kind of another way of looking at that picture. You've got a bunch of services. Now we can draw a box around our application, and the API gateway kind of paradigm is let's stick a proxy that sits between end users and the actual application. And we call that kind of traffic path the north-south traffic. So traffic from the users into your application. And in our API gateway, the foundation for this is Envoy. So with an API gateway, you need some proxy that is sitting on that request path. And Gloo is based on Envoy, an open source proxy, which I'll talk about a bit more in a few slides. So people often ask, well, what then is Gloo? If we're just using Envoy, why do we need something else? What is Gloo? And what Gloo is ultimately a control plane for Envoy. So we might refer to Envoy as a data plane. It's a proxy, but it needs configuration. It needs to know what to do when requests come in. And Gloo is responsible for managing that configuration. And we'll get into exactly how that works and why. But before we get into the Gloo components, we should start with just why Envoy. So when we were starting Gloo, we were kind of looking around. There are other products that fit the same kind of need with respect to kind of proxying traffic. But we saw Envoy, it was an emerging kind of proxy implementation coming out of Lyft, but now it's kind of owned by a neutral foundation where there's a huge, vibrant and growing open source community. It was built to be cloud native. So as we are kind of migrating towards Kubernetes, towards service mesh, towards adopting some of the cutting edge infrastructure, Envoy was designed with that in mind. It's highly performant. It's been stable and mature for a while. And it worked for that use case at Lyft. The other key selling point for us is just the ability to extend the proxy. So we're excited by the community and the kind of changes and evolution of Envoy over time that we've been able to just watch. But we've also needed to make changes ourselves. We've added features to our open source product, like being able to connect directly to AWS Lambdas. We've added features like more robust transformations. And when it comes to enterprise, we've added features in the realm of security, like the web application firewall. And this is logic that runs inside the proxy. We were able to build these custom filters ourselves, but still distribute Envoy, based on the upstream open source Envoy. One last thing to touch on here, we see that because of this, the ability to extend it and the large community, we see kind of Envoy is moving faster than any other product on the market. And we think that velocity and that gap is going to increase over time with the advent of a new technology called WebAssembly, which Envoy community is kind of looking at as a way to unlock the ability to customize Envoy in any language. So if you could run a WebAssembly runtime in the proxy, then you could potentially compile WebAssembly modules from JavaScript or Go or other languages, which would lower the barrier to entry for kind of building and sharing and distributing customizations to the proxy even further. So we're really all in on Envoy, and the Envoy informs how we've built Gloo. So now I'm going to talk about kind of the open source components of Gloo. There's 4 key components overall in Gloo, and I'm gonna try and be precise. The naming, we've overloaded the word Gloo here and a few of the words, so hopefully I can clarify that as I go. But the first component of open source Gloo is just the gateway proxy. So this is the actual Envoy instance. This is our data plane. The gateway proxy is just a container that we publish, as I said, with our kind of custom filters on top of a recent tip of upstream Envoy. And we manage that and kind of maintain that. So bringing in new critical fixes or new features and keeping that up to date. So that's the data plane. And then as we were talking about before, we need something to actually serve configuration. So the next component in Gloo, the first component of our control plane, is actually called Gloo. But what this is our the actual kind of server that is on the other end. It's the key responsibility is to send the configuration to Envoy. Now Envoy publishes in XDS a discovery kind of API or protocol for actually publishing the configuration. So it was really designed for this pattern. We are kind of sitting on the server side of it. In order to compute the configuration for Envoy, Gloo has a translation engine built inside of it. So basically what we need to be doing is translating some representation of what the configuration is going to be. So some kind of config that contains all of your listeners, all of your the ports that you're listening on and the domains and routes for those listeners and the features that you want on those routes. So we need some representation of that kind of config. And Gloo has a proxy object that does just that. Now I'm going to look at some of these and kind of talk about them as CRDs, as if they were stored in custom resources in Kubernetes, though it's worth mentioning, and I'll talk about a little more in a few slides, that's just a canonical representation. You could store this config anywhere. It's just kind of the way that we talk about it. So this is our proxy object. It's essentially an intermediate representation of all of the routes for all of the listeners. And this is the thing that is directly translated into Envoy's config. So I've got one of these, I installed Gloo. I've got one of these locally called gateway proxy in my kind of control plane namespace. And here's, if I go further down in the config, you can see on the listener, there's a set of virtual hosts which have associated with them some domains and some routes. And as we can see at the bottom of the bolded section here, a route configures both, on a route you have both kind of matching criteria as well as in action. And in this case, the action is to route to a particular destination, which is an upstream called the Pet Clinic Vets service. So upstreams are Gloo's upstreams are Gloo's abstraction for a destination. So the Gloo component of the control plane is ultimately kind of looking at all of your upstreams, which are your destinations for traffic. And then this proxy object, which is kind of the definition of all of the routes to those destinations. And then is translating all, is looking at that snapshot and translating that into Envoy config. Because of, one of the reasons we built this abstraction is so that we could kind of potentially enrich the routing information with additional information about the destination. So, here's an example where I've got a route to an AWS upstream, which has my credentials in it. So it can log in and see the Lambdas that are available to me. And then I'm actually, in this case, routing to a specific Lambda and transforming the response in a specific way. So that's what the Gloo component's doing. It's taking our intermediate proxy representation and it's looking at all of our destinations and it's translating that into the actual kind of Envoy configuration and submitting that to Envoy over XDS. Now there's a question of why do we need this representation? Or why do we even need to manage, something else to manage Envoy's config overall? And one of the fundamental reasons is the Envoy config is very verbose and large. So just having a single object, a single blob of config that has all of your listeners and routes and domains is quite a bit of configuration. And as we'll get into, by having this proxy, as we'll get into, the proxy object isn't exactly the thing that we're expecting users to write. Instead, we want to be breaking that up and exposing configuration to users in bite-sized chunks. And so I'll talk about in a bit what that looks like. So we have our routes to destinations. The destinations are these references to these upstream objects. So then the next question is often, where do these upstreams come from? And we want to make that as easy as possible and as automated as possible for simple use cases. So we've got a discovery component in Gloo, which has two different discovery mechanisms inside of it. So the first is called Upstream Discovery. Upstream Discovery is basically looking at your service discovery backend and determining what are all the services that are available and just writing out in upstream our representation of that destination to our config store. So if I immediately after installing Gloo and deploying a pet clinic demo application, if I list kind of my upstreams in the namespace, I can see all of these, and these were the kind of ones that were automatically generated. Now, as I mentioned before, you might manually author upstreams. Discovery is an optional component, but we wanted it there by default so that we get a nice getting started experience where you don't have to think about the destinations if you already have a service discovery backend. And we can see which ones have been discovered through a label on the resource config. Now, the second part of discovery is called function discovery. So the purpose of function discovery is to take upstreams that have been defined, whether they've been kind of automatically discovered or manually created, and then enrich those upstreams with additional information about specific functions that are available at that destination. So as an example here, we've got an upstream that's an AWS upstream. It contains below the fold here a secret that is my AWS credentials. But then the function discovery has gone and asked the Lambda APIs what functions are available and actually encoded them here. And in that way, trying to kind of make it easy to identify specific endpoints and make it easy to describe routes to those specific endpoints. And Gloo also has mechanisms for doing this with REST and for gRPC services. So if your teams are building REST services and they've published open API like Swagger specs for what endpoints are available, you can route directly to those endpoints in kind of the canonical way using that API spec rather than kind of trying to reverse engineer the paths. So those are the kind of the first three components, and that's what discovery does. Again, like discovery is an optional component, but it is something that we can use to really speed up the onboarding experience. It's also something that many customers have wanted to use at scale and in real production settings. So integration with service discovery backends is really important to us. I should mention that On the left-hand side of this picture, we've got secrets, config, and discovery listed. These are kind of our abstract. This is kind of just meant to indicate the underlying dependencies in terms of storage that we rely on. So we rely on a place to store secrets. If we're deployed on Kubernetes, this could just be Kubernetes secrets. If we're not deployed on Kubernetes, however, you might use Vault or some other secret manager. Similarly, for the config, obviously Kubernetes comes with etcd, a key value store, but if you're not on Kubernetes, you need to figure out other sources for storing that config. And again, if you're not on Kubernetes, you might be using other service discovery backends. So you might use something like Consul as an alternative here. We actually have Gloo users. All of our components are built with these three things kind of fundamentally abstracted away so that you can seamlessly deploy Gloo in Kubernetes, or let's say on the Hashi stack with Vault, Consul, Nomad, and get the same experience working with the Gloo APIs. Cool, so now I want to talk about the gateway component. And this is where we start to introduce really the user-facing configuration for routing. I mentioned before briefly that the proxy object that we have is a single object that is kind of the assembled view of the entire Envoy configuration. What we want to do is break that up so that we can decentralize the ownership of that config. We can kind of reason about, we can kind of pull apart things that and separate concerns for different domains or for different listeners, and make it easier to reason about and change the configuration without introducing any kind of risk. So the key abstraction for the user-facing API of Gloo, the kind of objects that users are writing to define routes, is called a virtual service. And it looks, a simple virtual service can look like this. Here I've got a virtual service called Pet Clinic, and it has a single, the virtual service has a single domain associated with it, which is star. So this is a wildcard, matches on anything. So really any request with any host on a request would match here. And then the route itself, there's one route, it has a matcher for the prefix /. So again, like any request that comes in will have that as the start of its path or URI. So this would match on any request coming in. And then in this example, I've routed those requests to a specific upstream called default Pet Clinic. So it's the Pet Clinic service and the default namespace on port 8080. On a virtual service is where we can start to introduce configuration options with respect to routing. So let's say, in this case, I've augmented the virtual service from before, and I've added a few things. So first, I've added an option at the virtual host level. So if I were to, so if there were many routes here, the option at the top says for any route to this virtual service, have a timeout of 10 seconds. So it's kind of a global config. You can kind of make configuration globally for all the routes associated with that set of domains. Or you can associate, you can also configure options on a route by route basis. So in this particular case, I've kind of gone ahead and on this route, I've added some additional features. So I've asked to rewrite the actual prefix before sending it forward. Potentially we're doing transformations, manipulating headers, enabling tracing. There's a laundry list of features that Envoy and Gloo expose as options on routing. We're going to get back to this a little bit later when we talk about some of the enterprise features and generally how you might ultimately configure auth and rate limiting and some other things. But for the time being, we'll kind of leave that here. Now, Gloo has a few other objects that optionally may be edited by users. So the first is called a gateway. And again, this is optional. So the component will automatically create these, or just, we kind of, by default, if you don't have any custom gateways defined, then we just kind of bind all the virtual services to the default listener. However, we can customize that behavior. In this case, I've introduced essentially a new listener for TCP proxying to a particular destination. I can also utilize this gateway object so that different virtual services are bound on different ports or use different protocols. So these are things that you might start to need to customize as you move out of a kind of a testbed environment towards a real production use case. The other thing that you might do on a gateway is enable global configuration for any request coming into a particular port. I don't have that in an example here, but if this was an HTTP listener, then we could potentially utilize any of the features that we support on HTTP routes, but at the listener level so that it applies everywhere globally. So with the ability to define new virtual services to kind of add new parts to your application and to enable new routes and customize the behavior of those routes. And then with gateway objects where you can actually customize what listeners exist on what ports and what protocols and which virtual services are associated with which listeners, that gets us a lot of the way towards satisfying our customers' use cases. But we have encountered still some difficulty with that. So if you're a customer where every route is associated with the same domain name, then there's the potential for your virtual service object to become very large because that single object with the single domain has to have every route defined on it. So what we wanted, and just like we were kind of concerned about a single proxy object being managed by users, it's similarly difficult for a single virtual service to be managed if it contains every route across every service in your application. So we've introduced one other abstraction called a route table, which basically allows you to, instead of defining all of your routes on a virtual service, you can kind of define a delegate object, which off of a particular path. So maybe example.com/marketing should be delegated to the marketing team's route table. And then the marketing team might own, /marketing/foo, all the services associated with that prefix. So this is another option in terms of kind of distributing the ownership and the management, decentralizing the management of all these configuration objects. And that's critical for ultimately kind of making this work at scale with large applications and hybrid kind of complex environments, and making it work as you're onboarding new services and bringing up new development teams over time. So just to summarize that picture, what we've talked about now is the gateway pod is basically the gateway component of the open source Gloo is basically watching those user contributed objects. They're watching virtual services and your routes and any other objects that might exist. And the gateway component's responsible for writing that proxy object. So rather than have users edit it directly, as we said before, we didn't want that. So instead we'll have the gateway object, the gateway component write that. And then when Gloo watches the proxy and it sees the proxy has been updated, it can push a new snapshot. And the nice separation of concerns here, we can, if the gateway component goes down, Gloo is continuing to serve configuration over XDS. If any other component goes down, the others aren't affected. So we've got a kind of a clean separation in terms of how we translate the configuration. So yeah, this is kind of the picture, just to summarize everything that we've looked at before we're moving on to enterprise features. And I'm gonna come back to this exact picture. So I'm gonna move ahead. Now let's talk about how enterprise Gloo has extended this picture with some additional components. So the first thing that usually comes up with potential customers is auth. So at that ingress point, as you're kind of thinking about your north-south traffic flow, you're certainly thinking about how do I authenticate users of the requests that are coming in? How do I authorize? So you potentially need to have multiple steps in your auth kind of chain. Maybe first identifying who the user is and ensuring that they have a real token, and then maybe checking that they have access to the specific resources. So Gloo comes with a bunch of, so Envoy has a hook, webhook endpoint for reaching out to an implementation of an auth API. And if that's hooked up to a route or to a listener, then the request comes in. Envoy on the request path will send that request to the external auth server, ask to check the request, and only continue down the filter chain and to route the request if the check is okay. Enterprise Gloo comes with an implementation of that server called external auth. And the external auth server has built into it a bunch of integrations. I think on the next slides, you can see some of the ones that we've worked with here. Gloo, it will work with any OpenID Connect OAuth provider. We've done specific integrations or extensions to support use cases around JOTs, around authorization with OPA or Open Policy Agent, LDAP, DEX, and other tools. We've also been working to kind of towards developer workflows and supporting API keys as a mechanism to authenticate and authorize. But the built-in implementations sometimes aren't enough, I'd say. So sometimes customers have some legacy authentication protocol that is truly bespoke, totally custom to their use case. And so Enterprise Gloo also has a plugin framework where you can write a little bit of Go code, and then we provide the kind of build container to build that into a dynamic library. We provide kind of all of the installation hooks so that you can automatically load that into your installation when you deploy Gloo. So we kind of try to make it easy to customize it, even if what you need to do is fully kind of implement a bespoke auth integration. And it's worth noting, we support this. Oops, sorry. We support this communication flow. So if we're looking at open source Gloo, it still has the ability to configure an auth kind of check on a particular route. It's just the enterprise product comes with this auth server implementation. Open source users would have to build their own server. Now, another key value add for our enterprise architecture are the customizations we've made to Envoy itself. And in particular, I want to call out Web Application Firewall, or WAF here. We've actually built a custom filter into Envoy. It doesn't exist in Upstream Envoy, nor in any other products that wrap Envoy, but we implemented it with the mod security library. And so this is a component that can easily be turned on and customized in order to kind of protect from malicious traffic. And it's something that has come up a few times as customers are kind of looking to move away from their legacy API gateway towards something like Gloo. Next is rate limiting. So with Enterprise Gloo, we ship a rate limiting server as well. And Envoy kind of treats this much like auth. So it's a similar kind of request out to another service. It's basically it's a check request, and then that service kind of responds yes or no. The logic is a bit different. There's a lot of rules around how you define counters. So like how you determine essentially the rates and where on which criteria or on which kind of descriptors you want to apply those rates. So there's a fair amount of configuration that goes into the rate limiting server. But Envoy has the hook to kind of plug right into that. And I should note, the main reason this is two separate calls, and the main difference between the auth kind of webhook and the rate limiting webhook is just the behavior in the failure case. So if the auth server were to respond with 404 or to not be available, the server would, Envoy would basically reject the request. Whereas if rate limiting goes down, then it lets it through. So that's kind of the key difference, and that's the reason there's two different webhooks. This introduces a concern with some people that, hey, we're adding extra latency, extra network hops, and I think this is both like an explicit decision about that trade-off. So the Envoy community kind of decided this was the right way to pull out auth and rate limiting from the proxy itself. Due to the amount of logic happening, you potentially don't want all of that happening in the same process. In the case that something were to go wrong, you might need to scale Envoy itself differently than how you need to scale the auth server. There's a variety of reasons you might do this, or you might want this trade-off. And to mitigate the negatives, there's different ways that we can deploy our external auth and our rate limiting server, for instance, on the same, as a sidecar to Envoy itself on the same machine, so that to minimize that latency as much as possible. And then the last key component of Gloo is observability. So the observability pod basically is responsible for watching the upstreams that you have across your Gloo configuration. And then it dynamically creates dashboards for each of those upstreams, showing things like error rate, total request throughput, and latency. So the latency through the proxy on that particular, or the latency to that particular service. And then Gloo integrates nicely with things like Prometheus and Grafana. So we can tie into your existing kind of metrics and dashboarding solution, or you can kind of deploy it with Gloo. And we've had customers look at integrating with other metrics backends like Datadog. So trying to expand those integrations over time as well. Obviously, I kind of didn't really mention this before, but Envoy, it natively comes with a bunch of observability features. So it publishes a bunch of metrics. There's easy hooks to enable tracing and access logging. So these all come, a lot of this stuff is just packed into open source Gloo. And then the other part of our enterprise offering is our UI. So this is a picture of the landing page of our dashboard. And we kind of view the value of the UI in a few ways. So first of all, just to kind of wrap your head around the product and how the translation from virtual services to our proxy representation to the actual Envoy config, just to kind of be able to see all the configuration in your system and how that translation is happening. When there is a problem, we can kind of highlight it here. So it's an easy way to kind of immediately get check the pulse of Gloo. And then finally, you can kind of do anything that you can do from the command line. You can edit either in kind of a nice user-friendly wizard, or at least in a YAML editor that the UI comes with as well. So you can really kind of iterate quickly and do so with added validation that the API server provides by kind of working with YAML in the dashboard. We do have a version of this that's available for open source. It's just read only, so the observability features are still useful even for open source. It's just the write capabilities, the ability to edit the YAML or edit these objects isn't there. And I personally kind of view this as really a modeling tool. So as you kind of move towards, in your dev environment, as you're learning Gloo, learning how to write virtual services, define routes, bring online new services, maybe learn how to upgrade Gloo, how to, all of your ops. This is a great tool in your toolbox. As you shift towards something like, as you shift towards a production environment, you're probably no longer you're probably no longer making edits to config in the UI. Instead, you're probably storing all that configuration in a repo somewhere with kind of an infrastructure as code mindset, and using tools, continuous delivery tools, maybe Flux, if you're on Kubernetes, to automatically kind of push configuration to the cluster. So Gloo, because all of our objects are backed by CRDs, and like the user-facing configuration is all can be expressed directly in YAML. We can kind of support both a nice user-friendly experience with our tools like the UI and the CLI, but we can also support a true GitOps workflow for production environments. Cool, and then the last thing I wanted to cover, we're getting to the 40-minute mark. I want to leave some time for questions, but maybe just walk quite quickly through an example here. So here, we're kind of like showing, okay, what is the life cycle of a request as it's flowing through Gloo? So maybe maybe our user-facing config, a user has added a route to a service on a particular prefix, and maybe on that service they've configured a few things. So let's say they've configured a particular authorization check involving open policy agents, and they've configured maybe some rate limiting based on a set of descriptors, maybe some based on headers or something in the request. And we might want to apply other features, say in this case, like a gRPC transcoder. So to translating an incoming REST request into a gRPC request that the actual upstream can handle. So the request comes in, so a user writes that in a virtual service, and then Gloo is, the components of Gloo will go and update the external auth servers config and rate limitings config, as well as go and update Envoy with those specific routes. So then when a request comes in, we can actually kind of trace the path. It kind of invokes the auth check. So the request gets sent to the auth server, which might come back as okay. Then it invokes the rate limiting request. It kind of reaches out to the server with its descriptors and get a response back. Then it can apply other filters in the chain. For instance, transforming this request into a standard gRPC request, and finally routing it. And then kind of on the response path, when the upstream responds, can kind of send it back and propagate the response back to the user. All right, so that's what I want. That's what I wanted to cover here. Hopefully, this gave a sense of the different components of Gloo, the different config objects that we expose, and kind of how those different components work with those config objects. And then importantly, I wanted to kind of touch on all the enterprise editions, like why do we have an enterprise product on top of the open source repo and the open source product, and then how does that all, why this is all based on Envoy. So a big part of that story is talking about how we work directly with Envoy. And with that, I think we can shift into questions.
Great. Rick, can you advance to the next
Yeah,
slide?
I was looking for that, yeah.
Yeah, so here's some links from that product page. You can do things like request a demo, or if you'd like to, download the open source or get started with enterprise. And then also if we've got a pretty active community in the Slack channel there. So there's always also other users in there in which you can ask questions. But we've got a few questions here. First one is, well, going back to the topic on decentralization, the question is, how does that work for teams? So what is centralized versus what is decentralized related to, policies, rules, auth, et cetera?
Sure. Yeah, great question. And my answer is going to be complex because there's a lot of flexibility. There's a lot of options. So some people will start to decentralize the configuration by using subdomains. So for instance, let's say example.com is my main application domain, and I could do marketing. I could have a virtual service with the domain marketing.example.com that has specific routes for the marketing part of the application. So you could then have the team own that virtual service and own all of the configuration for all of the routes on that virtual service directly. But if you're instead an organization where you kind of want everything to come into example.com, and then you want to use, let's say, a path prefix to determine kind of the team that request, the team that owns the service for that request. In that case, you might want to utilize our delegation feature and a route table. So that team can own a route table that says, any request coming into example.com/marketing, here are some additional routes off of /marketing, some kind of subpaths that then route to our specific services that our team owns. Gloo makes it pretty easy to determine options, whether you're on a route level or kind of these container objects. So you could have a virtual service that defines some default auth settings, some default rate limiting, other configuration that you want to apply to every route, and then you could still delegate specific routes to a route table, and that route table would thus inherit, with a configuration on the container object. So all of this, the route table, in that sense, is really just something that the gateway component only looks at. And it's just a way to kind of further break down and decentralize the ownership of like which teams get access to which objects. And the last thing I'll say is I'm kind of implicitly assuming that there is some RBAC, some access control rules in place. So this could be broken down by namespace in a Kubernetes cluster. Maybe the marketing team has access to the marketing namespace. They can only write configuration to that namespace. And what, so things, a way that we could make this work is the marketing team could own a route table inside of that namespace, and they're able to write that, but maybe they have no authority to write a virtual service, no ability to edit the virtual services defined in other namespaces. So that way you can provide, you can kind of delegate the ability to create routes and customize those routes without kind of handing over ownership of the parent configuration, or possibly allowing one team to disrupt another team's work.
So that's actually a good segue into the next question on what things should people consider when they're performing frequent updates to a route table for dynamic routing to ephemeral upstreams. You mentioned route tables quite a bit in your answer.
Yeah, so I think there's a few parts of that. Like it could be that I couldn't tell if the question was the upstreams are coming and going in that sense, they're ephemeral, or that the routes might be added and removed when those things come and go. Yeah, maybe both. So Gloo, like the underlying technology that we use, what provides our abstraction of the storage and all the things I was talking about, service discovery and storage is abstracted away. That's a technology we built called SoloKit. And what SoloKit does is let you create watches on our custom resources. And then we compute snapshots of the config, and then we can kind of run an event loop, and we can throttle that event loop. So, you may be really slamming the Kubernetes API server and like constantly changing this object, but we can try and throttle that. So we only can propagate config maybe once a second. So that's kind of our approach is, if a bunch of events come in for a particular object, we'll kind of batch them up on a particular cadence, and then push configuration out on that cadence. So we're quite flexible. I imagine there will be performance issues, things that need to be debugged if you're really stretching the limits of scale, but or of edits. But that could be also at the API server level. We could. There's ways that we can kind of tune that based on where those bottlenecks emerge.
Great. And there's a question here on, where is Envoy hosted? Is it inside Kubernetes? And the same question for Gloo. So the question is, does the customer need to, the end user need to host Gloo, or is it something that we provide as service? This is actually a pretty common question we get all the time.
Yeah. So we haven't really gone the SaaS route, so we don't really have a managed offering. We've explored it. It's a little bit problematic in the sense that how do you control the latency at that point? From the proxy to the actual application, or from the users to the proxy, it becomes a lot more challenging. You really want to kind of localize to some degree, at least, maybe regionally or in a data center or in a cluster, the proxy with your application. Just to finish the thought, the localization on the config path. So how Gloo sends configuration to Envoy over XDS. That's a little less important because that's not on the request path. That doesn't affect end user experience. So we have had customers that have deployed a lot of components of Gloo in Kubernetes, and have explored having the proxy in EC2. We've explored the opposite, and we've explored things like deploy everything off of Kubernetes on whatever other stack, like the Hashi stack. So we try to be flexible, but we don't have a SaaS offering. But we do support kind of, you can deploy in whatever hybrid, whatever specific scenario or hybrid scenario that you have.
Yes, so any cloud, or if you want to run that on-prem, you can run that anywhere. And if you're using Kubernetes, it can install onto the Kubernetes cluster, or you can use Consul, the Hashi stack for non-Kubernetes based deployments.
Yeah, those are the two ones that we've seen for production usage, at least. There's other ways that we could, deploy, but haven't seen those as much in production.
And if you're interested in something else besides those two, please reach out to us. We're happy to help you through it.
And like
Uh,
we've designed it to be flexible, so like we can add a new storage backend very quickly. We've done it for like files and for other kind of more hacky things, I'd say, but that are useful for the purpose of testing or demoing. But yeah, if there's new production use cases, we've built Glue to be highly flexible, and we can quickly make changes to support that.
okay, and there's a question here on how does Glue's tracing interact with something like Istio's tracing? Because integrating the gateway to the service mesh is actually is an active use case.
Yep. Yeah, so let's talk about that integration for a second. I actually meant to have that in my slides. So if you are using a service mesh like Istio, it's Envoy backed. What you really want is, your gateway proxy to talk to the sidecar directly. So, you don't want any other hops. You don't want to have to go through Istio's gateway in addition. Now, for some use cases, you might just use Istio's gateway or a really basic ingress. But for all the reasons that Glue is compelling that we've kind of went through, it may be compelling as a way to augment the service mesh, which is really geared towards your east-west traffic to handle your kind of north-south, your ingress use case. So we've worked out like a lot of details regarding integrating with Istio, Console Connect, and other meshes. Now, for the specific question of tracing, Envoy supports a bunch of built-in support like Zipkin, Open Tracing. Jaeger, I think, is the standard Istio tracing backend. So we can basically we can configure the proxies to be to compatibly so that we can kind of trace through both. And to some degree, but ultimately this is really exposing Envoy's capabilities. So we should be able to, with Istio, it's easy. Istio is based on Envoy, so it's pretty easy to keep those two configurations in sync.
Great. How do you configure IP whitelisting with Glue?
IP whitelisting, what's the context for the question?
Bashir, I apologize if I'm butchering your name. Could you add a little more context into the chat window where you asked that question?
Yeah, I'm just kind of curious, like, what's the motivation? Like, what are we trying to solve with IP whitelisting?
We will hopefully they respond to the question there.
Is there another one in the meantime?
Yeah. Can I build a Swagger Open API spec endpoint and Glue imports all the paths?
Yes, that's a feature of the function discovery module inside our discovery component. So yeah, we basically so Glue, once it knows about the upstream, once that upstream is written, which the upstream discovery mechanism might actually write itself, then it does the enrichment to detect the Swagger, the Open API spec, and then add the specific endpoints. And then you can route to those endpoints kind of canonically in Glue config rather than you have to kind of reverse engineer what's on that spec. It's important to note, we're also building out developer portal capabilities. So we want to utilize that spec and take it even further. So if your team's doing that and you also are, as a business, trying to expose APIs to the outside world, you should be able to publish a virtual service or routes of a virtual service as an API, and then users or developers should be able to log in to some kind of portal, see the APIs that are available, and actually kind of request access to them and do that. So this is a feature that we're actually kind of expanding on as we work out kind of more in the realm of the developer experience.
Cool. Let's see here. So Bashir did get back to us, and the context is the upstream service is open to the public, but they only want to allow specific IP sources.
Okay. Yeah. So both Istio and so ultimately Envoy does have some ability to do this. To be honest, it's a little bit out of my expertise. but I do know it's like it's something that you can do with both TCP and HTTP proxying. So I'm not sure exactly how you want to architect it, but this is a pretty common request for Envoy users. And so, yeah, I think there's kind of looking at, I'm actually like scrolling through.
Actually, Bashir, this might be a good follow-on if we can hop in the Slack together and discuss. So we can
Yeah, I would want to read up a little bit more on the specifics.
Yeah.
But I believe it's a capability of Envoy, so we should be able to support it. I'm kind of looking, actually, scrolling through. It looks like Istio has it. See, Envoy has something, IP transparency. Would need to study this a bit more.
Okay, great. And Bashir is already in the community Slack, so we can follow up and have a sidebar conversation on that specific scenario. Sounds like it's more curious on they're solving that with different products today, and was curious if this is something Gloo could support. Cool. So I think actually there's some additional questions in here, but we can go for one more, I think, for time. We've got a question here on, is there a dev model where they can config and test something without having it done kind of live in production?
It's an excellent question. This is probably the single biggest pain point that our users have experienced with Gloo, and I'll provide a specific example. So if you're authoring transformations, we use this thing called Inja templates, because transformations, you might want to do some pretty complicated stuff, manipulating the body or headers, other things about the request. It's really painful to have to translate translate Gloo config into Envoy config, send the config to Envoy, only for Envoy to reject it. Now that doesn't take down, your application. Gloo will continue to serve, Envoy will continue to serve the last known good configuration, but if we've, ideally we're kind of, as you say, kind of supporting a better developer experience. So there are kind of band-aid solutions that you could do now with respect to multi-tenant tenancy in your cluster. So you could have a different installation of Gloo that for development purposes. But the real answer that what we're working towards is incorporating this kind of validation into our CLI and in our UI. And what we want to do is basically spin up Envoy with the newly translated configuration as a way to test it and ensure that everything's working. And add things like that to GlueCTL check, so that there's a immediate way to kind of check the pulse of the configuration as well. So we're working out the details of that, but it's definitely a high priority kind of usability feature and something that's on the roadmap.